Question number 9. Y stands for a number. Y times y times y equals 5. The most accurate value for y to one decimal place is 1.7 because 1.7 times 1.7 times 1.7 equals 4.913. It then says k stands for a number and k times k equals 10. Find the most accurate value for k correct to one decimal place. Well, the method we're going to use for this is called trial and improvement. And basically it means trying different answers, seeing what answer you come out to, and depending on how far away it is from 10, improving your next trial. And the way you do this is you set the whole thing up with a table. In your table you're going to need 3 columns. The first column is going to be called our trial. The second column we're going to work out our answer. And in the final column we're going to say whether this is too big or too small. So let's put the lines in for the table. Obviously you would use a ruler for the next bit. Now we don't know yet how many rows we will need in this table. We may need more rows than this, we may not need all of the rows, we don't know yet. Now this is how trial and improvement works. We try a number first of all that we think might work. So let's try 3. So if our trial is 3, then if we replace all the k's with 3's, we would have 3 times 3 times 3, which we can do without a calculator. 3 times 3 is 9, times 3 is 27. And that is clearly too big. Why is it too big? Well, we're trying to make the answer of 10. So 27 is too big. Every answer we get, we're comparing back to this 10, so it's too big. So our trial of 3 was too big. So next thing we'll do is we'll try 2. Well, 2 times 2 times 2 equals 8. 2 2's are 4, times 2 again is 8. Now we're trying to make 10, so this 8 is too small. But we know that if 3 is too big and 2 is too small, the answer must be between 3 and 2. So the next logical thing to do is try something that's halfway between. Halfway between them is 2.5. So now we want to do 2.5 times 2.5 times 2.5. And this is where the calculator comes in. 2.5 times 2.5 times 2.5. And this equals 15.625. Which is too big because we're trying to make 10. So that's too big. So now the next sensible thing to do would be to go a little bit lower. Let's try 2.3. See where that gets us. 2.3 times 2.3 times 2.3. So 2.3 times 2.3 times 2.3. This time we get 12.167. Now you can see that we're getting closer to 10 because now we're on 12, but it's still too big. So let's drop it a little bit to 2.2. So we want 2.2 times 2.2 times 2.2. 2.2 times 2.2 times 2.2 is 10.648. And this is still too big because we're trying to make 10. So the next one to try, we already know that 2 is too small because that made 8. The only thing we haven't tried is 2.1. So let's try 2.1. 2.1 times 2.1 times 2.1. 2.1 times 2.1 times 2.1 does give us 9.261. Now that's less than 10. So that's too small. Now remember, in the question, we're trying to find the most accurate value to one decimal place. Now the most accurate value is going to be the answer that takes us closest to 10. Now we're only going to one decimal place, so there's no need to start trying 2 decimal places, and we know that the real answer must lie between these two, because 2.2 is too big and 2.1 is too small. Well, the question is, which gets us closest to 10, 2.2 or 2.1? Well, 2.2 gets us to 10.648, and 2.1 gets us to 9.261. So the question is, what's the gap? Well, from 10.648 to 10, if we do a subtraction sum, we're going to get 0.648. So this one is 0.648 away. If we do the 2.1 answer, which is 9.26, and find the gap to 10, well, 10 take away 9.26. We work that out on the calculator. 10 take away 9.26. That is a gap of 0.74. So that one is 0.74 away. Now the one which is least away is the one that's getting us closest. So which is least? 0.64 away or 0.74 away? Well, 0.64 is less, isn't it? That's a lower gap. 0.64 is lower than 0.74. So the one we need to go with to one decimal place is 2.2. Just to recap, we've narrowed it down to 2.2 and 2.1, and the answer for 2.2 is 0.64 away. The answer for 2.1 is 0.74 away. So closest to 10 is the answer that gets us to 10.64, and that's the one that comes from 2.2. So that's the value that we need. As a quick double check, if you did put your 2.2s in, well, we've already worked it out, so we didn't really need to check. 2.2 times by 2.2 times by 2.2 is 10.648. And that's the closest we can get to 10 with going only to one decimal place.